Hello and welcome to a video on the last triangle congruence shortcut, which is called hypotenuse leg. And this is a special case of what we will see in a minute is not always a good shortcut. But this one, in this special case, is kind of like side-side angle, but when the angle is a right angle and those sides have the special names. Remember, across from the right angle, always that's the hypotenuse. And the sides that are next to the right angle, those are called the legs. So what we say is if the hypotenuse, or in this case BC, segment BC, is congruent to segment EF, and a leg, in this case AB, segment AB, is congruent to segment DE, then we can say the triangles are congruent. So triangle ABC is congruent to triangle DEF. Okay, so with the addition of hypotenuse leg, we now have a total of 6 different ways to prove triangles are congruent. The first way is just the definition of congruence. This is just the definition. It's not even a shortcut. As you can see in the picture, every single part of the two triangles are marked as congruent. So there's no shortcut there. That's just the definition of congruence. Okay? The second one, side, side, side. The third one, we have side, angle, side. So that's SAS. The fourth one, angle, side, and an angle, that one is ASA. The fifth one is two angles and the non-included side, so that's AAS. And then the one we just saw, which we're not going to call it SSA, we're going to call it HL, hypotenuse leg. Okay? The two that are not congruent shortcuts, AAA, so if you have 3 angles, that does not prove that 2 triangles are congruent. And it shouldn't take a lot for me to say to explain that, because you're looking at it right here, right in front of you. You're looking at 2 triangles that have the same 3 angles. They each have the same 3 angles, and yet clearly those triangles are not the same. And you would never be able to do this if you had any of the cases above. That's the whole idea of the shortcuts. Once you know that 3 sides are congruent, you're not going to be able to make 2 different triangles like we did here with AAA. So this is not a good shortcut. And the same is true of side-side angle. Having 2 sides and the non-included angle, which is different from having 2 sides and the included angle, it's the non-included angle, doesn't necessarily make the same triangle. And you can see it right here, because these 2 triangles have the same angle, like this would be AS. Oh, don't pay attention to that, just think of it backwards. It's a bad word. It's, well, not really, it's just a donkey, but it's not a good shortcut. Okay, unless that angle happens to be a right angle, then the side across from it is no longer called the side, it's called the hypotenuse. The side next to it is no longer just called the side, it's called the leg. And that's the special case of SSA, which we call HL. Okay, now we're just going to look at some examples, and we have any one of these is possible, except it's going to be a shortcut. It's not going to be the definition. And we're going to go through the process that we've been going through, which is to label what we see by marking the diagram according to the given information and anything else we know, and then determining the shortcut from there. All right, so let's start this first one. So let's take a look. We've got the given information is that these are both right triangles. So the 2 little triangles are both right triangles, which means this is also a right angle. They're both right triangles. We also know that ML is congruent to MN. And although we're not given, we know that the side here is congruent to itself. So when we look at this, we see a right triangle, and this is the hypotenuse, and this is the leg. So this one is congruent. These 2 triangles are going to be congruent by HL. Congruent statement for this, triangle LMP is congruent to L corresponds with N, M corresponds with the other M, and P are both of the right angles. So they're two different right angles, but they're both with the vertex P. Okay, there's an example with HL. Now, just because it looks like a right triangle doesn't mean we're going to use HL, even if there is perpendicular. So let's see if this is HL or not. Let's see what happens. We do have perpendicular, so JN is perpendicular to LM. That means that these are both right angles. So right now, if I were you, I would be thinking, is this another HL? Maybe it is, maybe it isn't. Let's find out. All right, L is the midpoint of JN. So that means this L is right in the middle, so these two have to be equal. And of course, JM is congruent to itself. I'm just going to fix these a little bit, make them look more like right angles. Okay, so this is not HL, because this would be the hypotenuse, and it's not even marked. So what this is side angle side. The right angles, of course, congruent to the other right angle, side angle side. And so the congruent statement here would be that triangle JLM is congruent to triangle NLM. Okay, why don't we pause the video, try to mark this one, and see if you can figure out which shortcut this one is. Okay, did you mark your diagrams? Did you get angle, side? If so, great job. All right, let's look at the triangle congruent statement. So this is triangle ABC is congruent to triangle DEC. Okay, let's try another one. We'll pause the video and see how you do. Okay, how do we do here? So angle B and angle D are right angles. So I actually started to mark them congruent, and then I read that again, and I realized they're right angles. Even though they don't look like it, they look obtuse to me. But we have to go by what's given. That takes priority over what we see when we're talking about analyzing triangles. We always go by what the marks on the diagram or what is stated. And so we've also got BC is congruent to CD, and we've got the same side, AC is congruent to itself. So I am seeing a hypotenuse and a leg. Otherwise, it's going to be SSA. If you don't see this as hypotenuse leg, if you look at this as side-side angle, you should rule it out. Because if those weren't right angles, but they're just congruent angles, it would be side-side angle and it would be not enough information. However, this one is HL, and it is triangle ABC is congruent to triangle ADC. All right, let's try the last example, so pause the video. Okay, after marking the diagram, you should see side, angle, side. So this is SAS, and the congruent statement here, triangle ABD. I left out my A. Triangle ABD is congruent to triangle CBD. Okay, I hope you found this helpful. You now know all of the different ways to determine that triangles are congruent.